let's talk quantitatively a moment about pH curves. Now, specifically, we want to look at titrating something with something else. And typically, when we look at titrations, what we're looking at is a plot of pH versus the volume of titrant. Now, something to keep in mind with any titration, we never titrate with a weak something. The reason we don't titrate with a weak something is that the behavior isn't straightforward. We don't necessarily have 1 mole of acid for every mole of titrant we add. So when I say a titration, it's usually going to be something versus a strong acid if it's a basic solution, or it's going to be something versus a strong base if we have an acidic solution. Now there's 2 types of acids we can titrate, a weak acid and a strong acid. So let's look qualitatively at their behaviors. Now, if we have an acid, we're going to start down here beneath a pH of 7. If we are titrating a strong acid against a strong base, our curve is going to take this shape. Now what you're going to notice with this is that our equivalence point here is at 7. So when we have the same moles of acid that we do base, our pH is neutral. And this is always going to be true for a strong acid titrated with a strong base. But let's say we have a weak acid versus a strong base. Well, what we're going to see is, first of all, our equivalence point is actually above a neutral pH. And this is because when we completely neutralize an acid, we're left with nothing but the conjugate base. The other qualitative trend we're going to notice is what's called the curvature. So I'm going to draw this line a little bit beneath the strong acid curve. Now for the strong acid curve, this curve is always going to curve upward. So we have what's called a positive curvature, or upward curvature. This isn't true for the weak acid. For the weak acid, when we get above the midpoint, so midpoint MP, our midpoint is half the distance between the equivalence point and 0 milliliters of base. We have a positive curvature, but beneath the midpoint we actually have a negative curvature. And that's because the midpoint serves as an inflection point. It's a change in the curvature of the curve. Now, this switch from a negative curvature to a positive curvature is only true for weak acids. If you have a strong acid, you're always going to have this curve upwards. What about if we look at a base? So a base versus a strong acid. Again, we're going to have our starting curve, our starting plot. Because we're working with a basic solution, we're going to start above a pH of 7. For a strong base being titrated by a strong acid, we're going to see a similar trend just reflected over the pH equals 7 line. Our curvature is down in this case, but that's because we're trying to go to lower pHs. So we've got to slope downwards when we're adding strong acid. Once again, our equivalence is at a pH of 7, and then we're going to get the behavior of the strong acid we're titrating with. If we are titrating against a weak base, we're once again going to see this change in curvature. So if our midpoint is here, above the midpoint, we're going to have a positive curvature. Beneath the midpoint, we're going to have a negative curvature, and at equivalence, we're actually going to have a pH beneath 7 because when we completely neutralize a weak base, we end up with a conjugate acid. This is going to give us an acidic solution. So qualitatively, in terms of a pH versus titrant curve, these are the differences you're going to be able to see. So if you're looking at a graph and you're trying to figure out, well, am I titrating a weak acid or a strong acid or a weak base or a strong base, first of all, figure out what pH range you're starting at. If you're starting above 7, it's a base. If you're beneath 7, it's an acid. If you're titrating, it's always going to be against a strong something. So if you're starting with an acid, it's against a strong base. If you're starting with a base, it's against a strong acid. The curvatures are going to tell you if you're working with a weak or a strong. If the curvature is always the same, so for a base, always pointing down, for an acid, always pointing up, that's a strong acid or base. If you see curvature one direction beneath the midpoint and then the change in curvature on the other side of the midpoint, this is an indication to you that you have a weak acid or a weak base.